Hey everybody, in this video we are going to complete the identity sec𝜃 minus 1 over sec𝜃. So let's dive right in. So the way I would start this example, and you have a few options, but if you choose to work with secant, that means you're going to have to perhaps reference the trig identities that involve secant, and some people are just better at the ones that involve cosine, specifically referring to the Pythagorean identities. So I'm going to start by kind of doing a little flipperoo, and I'm going to change my my secant(x) or secant theta into 1 over cosine theta, and then minus, instead of 1 over secant, I'm going to write it as cosine. So really, I just sort of inverted everything in this step. Now, what I'm going to do, remember, when you're completing an identity, you're simplifying, you're bringing everything together. So I'm going to bring this together by finding a common denominator. So this cosine theta is over a 1. So I'm going to multiply on top and bottom by another cosine theta. These steps are worth a little bit of time to think them over, kind of get an idea of like, well, what would happen if I did this, if I did that? So by doing this, we can now rewrite this as one fraction where cosine theta is the denominator, since it is a common denominator, and we're going to write this whole section together. And then we'll have 1 minus cosine squared theta on top. From here, so I'm not using equal signs, I'm kind of doing arrows, like this implies this, which implies this. I'm just going to save a little space. I'm going to go this way. So what I'm going to do now is I'm going to apply the Pythagorean identities. So up on that little pink post-it in here, if I subtract cosine squared theta to the other side, you'll have that sine squared theta is alone, and it equals 1 minus cosine squared theta. That means I can substitute in sine squared theta for the numerator. When all is said and done, when you have successfully fully simplified or completed an identity as far as you possibly can, it's usually going to end where you have no plus or minus signs, ideally, not always, but typically, and we're going to try to avoid a denominator. So how can I get rid of a denominator? And you can almost always get rid of the denominator. So how am I going to get rid of the denominator here? Well, what you're going to do in a situation like this is we're going to separate sine theta into sine times sine. And when it's over cosine, because it is not a sum or a difference on the numerator, you can't like pretzel and divide each of them by this. This is just the product on top. So what I can do is I can just kind of look at that together and leave the other sign there. So what does that mean for us? That means we have sine theta times tangent theta. You don't need the dot for multiplication, of course. They could just be right next to each other, or you could use parentheses instead, whatever you prefer, all right? So I hope you are able to understand the procedure I used to fully simplify this into like the most ideal format. If you did it a different way and you're curious if your way is valid, go ahead and put it in the comments below. And if you feel fairly good about the work you did on this example, go ahead and give the video a thumbs up. If you don't feel confident with this at all, go ahead and give the video a thumbs down. Click through for the next example, and I hope you feel a little bit smarter after this video. Adios.